Okay, then I'll see if I can record it. A and B are position vectors 2, 1, 2, 3, negative 2. Okay, before this, right, I just want to recap with you all something. Okay, very quickly, without looking at your notes, without looking at your notes, can you help me write down? Okay, never mind. Okay. Okay. Hey, Ian, take out your notes. Stop. Carl, shut up. Okay. One more time, Carl. Okay. Okay, so all these are recorded. So I'll show this to your parents. They'll know that you are talking rubbish in class. Okay. For p equals to negative 8. Okay, for p equals to negative 8, find the length of projection and projection vector of OB onto OA. Okay, so length of projection, right, and projection vector, there's a difference. Like I say, right, you must know who is the one being projected upon, who is the one that's projecting. Okay, so the one, recall again, in your notes, you have studied this. Don't know, go and force yourself to memorize. If I project A onto B, okay, who provides a unit vector? B, because, okay, so this can be a length, this one can be a vector. So this vector here, right, this vector here is a shadow. Okay, so this vector over here, we call it the vector of projection of A onto B. Right? So for this, we call it A dot product with B hat multiplied by B, no bracket, don't need bracket, multiplied by B hat. Okay? Can this proof is in your comprehensive notes. Okay, I'll make a video if you need then, but you must remember, this one every year come out one. Vector projection length. So the length of this, right? The length of this is just the magnitude of this. It's just the magnitude of this. So, but we will take the length of the projection is just the same as length of the vector. Length of projection of A onto B, right? This is equals to the magnitude of this. Am I right? So if I take the magnitude of this, I'm finding the magnitude of A dot B hat. Correct? Then I can split the modulus, right? Right? What's the modulus of B hat? What's the modulus of this? What's the magnitude of this? Just 1. So I can throw it away. That's why this is the answer. So the final answer is just equals to A dot product with B hat. And ta-da! That come out, that's the answer. Okay? Must memorize, you must know. Okay? If you can, I can show the proof. It's very straightforward. It's just using Sec 2 Tokaso trigonometry. So with this, right, we go back to P equal negative 8, length of projection of OB onto OA. OB, as you know, okay, this is just for part A, right? P equals to negative 8. Okay, we are just finding OB onto OA. So answer is just OB dot product with OA over its own magnitude. Okay, OB, right, onto OA. So OA provides the unit vector. It provides a unit vector. Correct? Okay, so B onto A. Length of projection is just B dot A hat. Okay? 可以吗？可以哦 can哦 So you want me to show you the proof for this? Why is it like that? No need? No need. They don't ask. They just ask you to do it. Okay, just do it. Okay, so you also must know. Okay, so after that, it's just OB. What is OB? OB is equals to 3 negative 2 8. What is OA? OA is equals to 3 negative 2 1 2. So it's 2 1 2. So it's 2 1 2 divided by its own magnitude. What's the magnitude of OA? It's just square root 2 square plus 1 square plus 2 square, which is just 3. We just 3. So I just put a 3 outside. This one I can put outside. Correct? Then inside you just cross 3 to 2, negative 2 to 1, 8 to 2. Like that can already. The answer come out. 1 over 3 inside you actually have a negative 12. Negative 12. Okay, negative 12 over 3. Modulus of magnitude of negative is 12 lah. So we have actually 12 over 3. Our answer is 4. Okay? And how? I did the same in the video. This one I'll record when you watch. Okay? Then part B. Part B. For P equals to negative 4, calculate the shortest distance from B to the line passing through O and A. Very simple. It's just like this. Okay? All you need to do from B, O, B, A. That's all. Okay? So there's a lot of ways to do this. So what's the revision? Revision, okay, revise very quickly. Let's say if I give you A, this is B. Okay? How do we calculate this? This shorter distance. How do you calculate the one in red? Let's say I just use the A and B, A and B. OA, A times A dot B hat. Cross. One is scalar product. Scalar product give you a scalar. Vector product give you a vector. So actually it's just A dot B hat. This one is the length. Okay? If you talk about the vector, then it's just A times B hat. That's all. This will give you the vector. This will give you the length. Okay? They call it the length of the perpendicular component onto B, something like that. Okay? Length of the perpendicular component. Okay. So revise this, revise this. Okay? Yeah, it's in your comprehensive notes, like the last, it's the last one. Okay? Can With that, okay, look at for P equals to negative 4, calculate the shortest distance from B to the line passing through O and A. From B, O, B, A. The line passing through B and A. All we are doing is, let's say if I call this B, right? B is equals to 3, negative 2. P is negative 4. What is A? A is 2, 1, 2. Right? So all we are doing is we can take, very quickly, we just take B times A hat log. That's what we can do. Alright? In our question, they don't have B. They call it actually, this is the OB multiplied by OA over this O magnitude. Alright? And very quickly, you can solve this for yourself. Okay? And anyone can get the answer? Carl, what's the answer? For question 1D. Square root 245. Okay. Can you divide the answer by 49? Square root 245 over 9.
Yeah.
Over 9. This one, I believe, is the same as square root 49. Okay? Should be over 3. I don't think. Final answer is 7 root 5 over 3. I think quite close. So it's the answer, huh? Answer is 7 root 5 over 3. 7 root 5 over 3. You use a calculator. I think it's the same. Square root 245 over 9. Square root 245 you divide by 45. Cannot. Divide by 49. So it's square root 49, square root 5. Square root 49 equals to 7. 7 over 9. Wrong. Answer is over 3. Also over 3. Square root what? Is answer the same? Is the value the same? It's okay. Preferably the answer rationalize. Must rationalize. Must rationalize. Okay? Okay, so some of you cannot get, so let me just show some of you cannot get. OB, what is OB? OB is equals to 3, negative 2, negative 4. This is 3, negative 2, negative 4. Vector product, OA is 2, 1, 2. 2, 1, 2. The magnitude over here is 3. So can I put outside? Can I put 1 over 3 outside? Can. Very quickly, let me recap with you. Okay, A, vector product with B. This is the same. Lambda A, vector product B. This is the same as lambda of A times B. Okay, children? You must know. It's not very useful one. Later you know. Okay, then, so over here, this is 1 over 3. Over here, vector product, very easy. Okay, vector product, do you all know the standard? Like, are you able to memorize the method? Okay, have you all read the lecture notes, the comprehensive notes? The comprehensive notes will tell you how to do it, right? Okay, so I did a video on it. Go and watch the TV. Lecture. Okay, very quickly. Vector product. Let's say if I take A1, A2, A3, vector product with B1, B2, B3. Okay, very simple. Before you even start, you just write another 2 rows. A1, A2. Right, repeat. B1, B2. Okay? You want to find the first component. First component, right? Okay. First component I cancel. I take these two. A2, B3, A3, B2. So this one is A2, B3 minus A3, B2. Second component I cross. Okay, so again. Okay. Let's say if I want the second component, what I do is using the second row, I crisscross the third one. Okay, so first component, A2, B3 minus A3, B2. I want the second row. For the second row, I put 2 rows underneath, I cross A3, B1, A1, B3. A3, B1 minus A1, B3. Okay, third component, I want the third component, I cross the third row, take the 2 rows underneath. Okay, A1, B2 minus A2, B1. Alright, whatever row that you want, cross that row, crisscross the row underneath. Whatever row you want, okay, take that row, crisscross the 2 underneath. That's vector product. Okay, okay. Sorry, very boring one. Must know. Also sure come on. All these are fundamentals. This vectors part 1 is warm up only. Well appetite. Train you to do basic jump shot, do the basic dance step, how to flip your fan, how to do the normal pedaling before. Then vectors part 2 is the actual game. Means you go and really play the game. Combine all the game strategy. Combine all your dot products. How does it apply? Vectors 2, if your part 1 not good, your part 2 die. You don't know what you're talking about. Okay? So this is part 1. Okay? So with that, over here, answer you should have. In the end, you should have a modulus of 0, negative 2, 1. How do you get this? 0, negative 2, 1. Then you check. Maybe that means your vector product wrong. Okay, so you just okay. So answer 7 root 5 over 3. Which one? Oh, because I pull out the 7. I pull out 7. That's why 0, negative 2, 1. Because it's a scalar. It's a scalar, The scalar can pull out. You can end up with this 1 over 3, 14, You can end up with this 0, negative 14, 7. You can end up with this 7 over 3, 0, negative 2, 1. Both are the same. Because scalar can pull out. Scalar can pull out. Scalar can pull out. Okay, then that's for part B. 1C. Question 1C. Find the value of P for which OA and OB are perpendicular. Very easy, right? Perpendicular vectors here means what? Tell me, what does it mean to you? Times your head. Times Use the correct terms. The dot product or scalar product equals 0. Why? Why is it equals 0? Y equals to 0. Yuki, why is it equals to 0? Cosine 90 is 0, Cosine 90 is Claire, why is, okay, so let me say again. Okay, A dot B cosine theta. If this one equals to 90, cosine 90 equals to 0. That's why whole thing 0. Okay, 0 times whatever rubbish to 0. So this equals 0. Okay? Can Okay. Next. So question 1C. For OA and OB to be perpendicular, you just need 2, 1, 2, dot product 3, negative 2P equals to 0. Right, so solve this. 2 times 3, 6. 1 minus 2, negative 2, plus 2p equals to 0. P equals to negative 2. Like that. Answer come out already. Yeah, okay. After that, 1D. Question 1D. Easy, right? Easy game. Right. I need to find P equals to 6. Find angle AOB. AOB, all I need to do, I take, you still remember how to find cosine angle? Okay, Kalisa, come tell me the formula. Cosine AOB equals to what? OA dot with over OB more. Okay, very good. That's all. Okay, then after that, 2, 1, 2 dot product 3 negative 2, 6 square root 9 square root 49. Answer come out 16/21. All can get this? Can Then AOB, all you need to do, you just cosine inverse. Cosine inverse 16/21. Answer asks for nearest degree, right? So approximately 40 degrees to the nearest degree. Yeah, and that's all. That's all. Okay, all these are fundamentals. Finding scalar product, understanding what is length of projection, understanding what is a vector of projection. Okay, all those are fundamentals you must know. Okay, 1E. Then 1E requests for us to find where P equals to 5. Find the position vector of the point M on the line segment AB such that AM, AB is 1:2. Notice I have a habit, I underline the key points. Also, just go slow. You see a ratio, what comes to your mind? Okay. What comes to your mind? Use ratio theorem. That's all. Okay. Ratio theorem. So ratio theorem. Okay. So AB. A, this one B, right? OM is here. This one is your O. This one is your M. Okay? Then OA 2, OB is 1. Like that. Okay? Then we just crisscross. OA is 2, 1, 2. OB is 3, negative 2, 5. Ratio theorem is crisscross. This one to this, here to here. Like that. Then with that, then very quickly, okay, OM equals to 2 of 2, 1, 2 plus 1 time of 3, negative 2, 5 over 1 plus 2. Answer come out. Then from here, I think slowly you all can solve. You get 1/3 of 709. Anyone cannot get? Whether is it a careless mistake or concept mistake, both also cannot. So remember, your essay. Can. You can also present it this way. This is fine. Same. Okay? Can. Okay, next one. Question 2. Any problem with question 2? Answer, okay. Okay. You notice this one actually is in the Tuesday, the Monday, the quiz. Yeah. Answer, okay, very quickly. For this one, P will be equals to 1/7. A dot B, this is the length of projection of B onto A. Okay, do you all know why? Okay, very good. Okay. Anyone don't know this? Don't pass it. Very small group, very cozy one. So when we do geometrical interpretation, means like there's only a few that we've learned. So the interpretation is that it's the projection of B onto A. Yes, sometimes. Very worse. Sometimes they will ask. But if you look at this, it's very like trivial. It's very direct. It's something you already studied. We want to give you something very different. And what about the okay? So you understand why is it B onto A and not A onto B? Because A is a unit vector. The one with the unit vector is being projected upon. Okay. Remember, A like B onto A, right? If you are finding the vector of projection, This is B dot product with A and A hat. But if A is a unit vector, if A is already a unit vector, means that A is equals to A hat, correct? So what are we talking about? Nothing. It's just A is already equals to A hat, right? Right. So this is already the length of projection. This is already the length already. So modulus this is already the length. How about modulus? Magnitude A times B. What is this? One interpretation. Remember, you study one use of vector product is area, right? What kind of area it gives you? Jia Xuan, this one what kind of area does it give you? Jia Xuan, look at me. Don't ask me. Try. Come on. Rectangle. Must it only be rectangle? Trapezium can or not? Can Can you go and call police Okay, cannot. It's a parallelogram. Okay, must be a parallelogram. Okay, so you must know this. Okay, so since okay, I've tested you and I realized you don't know, let me just recap. Okay. Area of triangle. Okay, if you have two vectors A and B, right? What is the area of this triangle? Jia Xuan, what's the area of this triangle? Option 1, half A. Option 2, option 3, option 4. This is A times B. Vector product with. Then what is B times A? It's just point there. You see. So the thumb is pointing towards. This is like negative B times negative of A times B. It's the same as negative B. So actually they are the same. You actually, if you realize, right, you do your questions, you realize for measuring angle, it must be tail to tail, head to head, right? But for finding area, doesn't matter. For finding area, you just take any two sides. Doesn't matter where they point. I thought it's adjacent. So if you find A like that, right? One is B this way, right? You want to find the area, right? You just take A to half of A. Doesn't matter. Don't need to be head to head. How? What did I say? You don't play with the fan, Have you seen what I can do with the fan? No, I cannot. I just scare you. You don't do. Okay, Okay, so yeah. So the truth is A and B, B and A both can. Both can. Okay. How about parallelogram? Split into half. So it's just A times. Yeah, that's all. Okay. Must know. Okay. So you don't know if really so put nicely if you don't know, go and die. You really don't know. You ask you find area, you cannot find. A-level questions are not like school time, they are very direct. Just give you 2 marks, go and find area of A and B. Cannot find, then you give the 2 marks away. You must know have the fundamentals. Okay. Next one, geometrical interpretation of C, right? Okay. So this is one. You can say this is just an area of parallelogram. Okay, the area of parallelogram. Okay, very quickly. Okay. Then question 3. Question 3, any problem? A, B and BP. Okay, if you use A, B, okay, so okay, so if you use A, B and BP, right, you need to say that, okay, AB is a scalar of BP. On top of that, they share a common point. Okay, share a common point which is B, which is B like example. AP then no need. AP, what you're doing? Okay, so there's a difference. AP, if I show AP, right, then I show BP, right? It's already part, it's a sub line of the whole line. But if you show AB and you show BP, right, it means you're just showing that two lines are parallel. But if you need to show that they have a common point, right? Then you are joining them together. You are joining them together. If it is B. So if you are writing two separate lines, you are proving this and this have the same gradient, but you must show that they have a common point. Yeah, but if I want to show that this and this are parallel, because it's really part of the line. Okay, so for here, for this question, pi okay or not? Know how to show? Can get? Does it can? Okay, then I skip. Cannot do. Then Maybe I skip part 1. Okay, then part 2. Find the value of lambda such that P is on the line BA produced. BA looks like that. So we say, this one is B. This one is A. Okay? P is on the line BA produced. Area of OAP is 162 square root 5. OAP, we don't know what it looks like. So let's just draw. Okay, OAP, maybe it looks like this is O, this is A, this is P. What can we do? Just take two, maybe take these two. How about that? Can we say that the area of triangle OAP is equals to half of AO multiplied to AAP? Correct, right? Okay, right? Can, with that, we just find out what's AO. AO is what's AO? AO is, okay, so this is half 1, 3, negative 2 negative of OA Okay, what is AP? Very good. Okay, so if you did your part 1, right? Count okay. AP will be lambda plus 1 over 3, 6, 3, 0. That will be the part. That will be AP. Yuki can get. Cannot get. I go next page, show you very quick how to find AP. AP is equals to OP minus OA. Okay? What is OP? OP is given, right? OP is equals to 1 plus 2 lambda, lambda minus 2 and 2. OA will be given by negative 1, negative 3, 2. Okay, I know I'm very boring, I bear me for okay. Okay, then like that, so you just get AP to be equals to lambda plus 1 over 3, 630. Okay? Can work it out, Okay. So with that, right, we have this. Then, can I summon what I did just now? Remember I said this, right? A plus lambda B. A plus lambda B. A times lambda B. This is the same as lambda A times B. Sorry, I'm using as effective product. Yeah. So I can take out. So lambda plus 1 over 3. I can take out. This is the same as lambda plus 1. 2 and 3 become 6. Okay. So this will give me 1, 3, negative 2, 630. Okay? Can. So I do this. Is it possible to simplify the 630? I can take out 630. I can put this as 3 bracket of 2, 1, 0, right? Can. This 3 I take outside, I put here, can, right? Then this 3 I cancel, I get 2. Can I? So what I have is just a lambda plus 1 over 2. Magnitude of 1, 3, negative 2 times 2, 1, 0. That's the answer. You must remember, you are finding area. You are going to produce a scalar, something in unit square. So this, some people they forget this sign. They forget this. How I know? Because I also forget. You must remember. Okay? Can. Solving this, you should have. This is Okay, on the right hand side, we know, okay, lambda plus 1 over 2. Okay, rewriting what I have just now. 1, 3, negative 2, 2, 1, 0. 1, 3, negative 2, 2, 1, 0. What does the question say is the value of this? What's the value of this? It's actually 162 square root 5. Can, right? I take away the 2 on both sides. Times 2, this one will become 324. Okay? Lambda plus 1. Okay? This answer will give me square root 45. Oh, you want me to show from the how to get from here to here? Want me to show? Can do that, yeah. I scared I show too much, you all get very bored. So, okay. So 325. With that, lambda plus 1 square root 45. Sorry, lambda plus 1 equals to 324 square root 5 over square root 45. Okay? Sorry, modulus. And you can solve. Alright, eventually you will get lambda plus 1 equals to 108. Lambda plus 1 equals to negative 108. Can get these two? Cannot, is it? I try. I have the same direction and the same length. So if I, for example, I give you the vector 1, 2, 3 and I give you the vector 2, 4, 6. Strictly speaking, they are not the same, but they have the same unit vector. Means if I take this, I chop, I find one unit length 1. Length 1 is the same. Okay, very quickly I'll show you this. What's the unit vector for this? 1 over square root 1 square plus 2 square plus 3 square. 1, 2, 3 equals to 1, 4. 9 plus 4, 19. 9 plus 4, 13. Square root 14, right? This vector over here, 1 over square root 2 square plus 4 square plus 6 square. Here, this is 2, 4, 6. What is 2 square plus 4 square plus 6 square? 36 plus 16. 36 52, 52 plus 56, right? 1 over square root 56. This is the same as 1 over 2 square root. Right, this one I can take out 2, right? This one I can take out 2, right? So I take out 2. 1, 2, 3. Cancel. Can you see? Both are the same. Can you see what I'm saying? Yes. Why do we need to find a unit vector? You can see when they first call unit vector, right? What was the application? The application was later on you need to find length of projection. Like, the length of projection, so the definition is like from A onto B, right? Let's say from A onto B, correct? Then the length of, let's say we want to find this, right? I shine a light here, shine a light, got some song on it. This is the shadow. This shadow, the vector of this shadow is A, dot product with B. Okay. Most of the time, what will they do? They will not give you unit vector, they're going to find the B. They'll give you B, then find the unit vector. So they'll tell you B equals to like 7, 8, 9, so they'll give you B, then you go and find the unit vector. Yes, correct. But you can show one. You just homework, you go to the appendix notes, you go and read the appendix. The appendix it tells you why is the formula like this. Why is the formula like this? Okay. Vector product A and B. So very quickly, right? OACD looks like that. OACD looks like that. O, A, this is O, this is A, this is C, this is B. They tell you already, stupid question. Give me a parallelogram. So all you need to do, I just D is somewhere here, D is somewhere here. Okay, D, O, A, C, D. So D is somewhere. This is the one that we are finding. So you agree with me? Actually, area of OACD is the same as area of OACB minus OBD, minus area of OBD. Correct, right? So what is area of OACB? OACB, this one we know, this one is A, this one is B. So it's just magnitude of A times B now. What's OBD? This one is OB. What's OD? Anyone know? This is what is? OB. Anyone? So OD was actually found in the was found in A, right? Was part A. You see, it's actually lambda A plus B. As clear attention, or it's just A plus B. Okay, so this area of OBD. Okay, let me just write the side. Area of triangle OBD is the same as half of OD vector product with OB. Correct? This is just half of lambda A plus B times B. Okay, so this is just, okay, I'm going to confuse you a bit. Okay, so somewhere in your earlier life, they tell you this. Half, if I take A plus B vector product with C, okay, this is the same as A vector product with C plus B vector product with C. Okay, this part. So, like scalar product, vector product, both are distributive. It's like algebra, I can distribute one. I can distribute the A, I can distribute the B. Very caring, very sharing. Okay? So, I can distribute. Distribute. So, here, that means this portion, we can do that. We can take out the lambda first. I take out lambda first. This is A, B plus B times B. What is B vector product with B? Count. Don't look at anyone, look at me. Tell me what's B vector product with B. 0. Very good. Why? Desiree, why is vector product B and B 0? Because B is parallel to itself. Two vectors are parallel. The vector product is 0. So this one will be just equal 0. Okay, so that means this answer over here is just this. It's just a lambda over 2 A and B. Okay. So with that you have A minus A like that. Okay, so I can put a 1 here. 1 minus lambda over 2. 1 minus lambda over 2. Vector product of A and B. That's all.